this. Let me pull up that, let me pull that up and then we can go over whichever ones you want. Okay. All right, what number are you looking at?
Could you go over number 12?
Sure. Okay, so for 12, we need to find S. So S, remember, is arc length.
Mm-hmm.
So that's, if you were to literally walk, you imagine that this was a giant circle and you literally walk from here to here, it's that length in feet or meters or inches or whatever units we're in. Okay. Mm-hmm. And the formula to find S is just S equals R theta. R being the radius, and then theta just has to be your central angle, but it has to be in radians.
Okay.
So that's the crucial thing on this one, because they didn't give it to us in radians, they gave it to us in degrees. So before I can figure out what S is, I need to change 100 degrees into radians. So if you, let's see, I'll just do it down here. 100 degrees, to turn anything in degrees into radians, you're just going to multiply it by pi over 180.
Mm-hmm.
So I can make my life a little bit easier. I can cross off the zeros on the end of each one, and now I have 10 over 18, so I can reduce by 2, so that would get me 5 over 9. So that means 100 degrees in radians is 5 pi over 9. So if I come back up here, S equals, my radius is 15, and then theta in radians is 5 pi over 9, we said. 5 pi over 9. So now I'm here, and all I have to do is this math, but again, I can reduce first if I want, just to make my life easier. So I have 15 over 9, so I can reduce by 3. So 3 goes into 15 5 times, 3 goes into 9 3 times. And so now if I just multiply straight across, I'm going to get 25 pi over 3. Now, if I look at my choices, none of them look like that, mm-hmm. right? So that's when they've basically just taken, they just turned it into a number. So I'm just going to do 25 on my calculator, 25 times pi, and then divide that number by 3. And I get 26.17, blah, 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 blah. So if I'm going to round that, I get choice C, 26.
Okay.
Does that make sense?
Yeah.
Okay. And do you have your reference sheet, right?
Yes.
Okay. So I was just going to tell you that formula is right on the reference sheet. So it's not anything that you have to memorize. It's
okay.
Yeah, it's back there. Okay. Any other ones from this particular?
Yes.
Okay, go ahead.
Could you do 20?
Sure. Okay, oops. Let's see, 20. Whoa, whoa, whoa. Okay, there we go. Oh, these pulleys, yes. Okay, let's make sure that I can do this without messing up, because I usually do. All right. So we have the 2 pulleys of radius 6 and 10. So let me try and draw them. So you got a little pulley here with a radius of 6. And then you have a big pulley here with a radius of 10. And then you have this belt that's going around the 2 of them. So let me draw the belt. Okay, so the pulleys are going to spin and the belt's going to spin around the 2 of them, right? Mm-hmm. So here's what we know. The larger pulley rotates at 40 times per minute. So this value, this 40 times per minute, that is, that's that funny W thing. Oh, no, it's not. Yeah, it is. Yeah, because it's rotating. So that's going to be, let me switch colors again. So that thing's angular velocity is 40 times per minute. But I need the angular velocity of each. Wait, am I doing this right? V equals RW. I need to find, but I have to change this into, oh, that's right. I got to change this one into revolutions or radians, right? So I have 40 times, let's make that revolutions in 1 minute. But I need to change it into, do I need it in degrees? Why can't I remember now? Jeez. I know I did a video on this one, but now I can't remember how I did it. The larger pulley rotates, find the angular velocity. So angular velocity is my W theta over T. Oh, how did I do this one? I think I had, we were using V equals RW, and I remember the velocity of the belt's going to be the same for each of them. So I think I just, oh, that's right. I think I just saw for each one. Hold on. Let me erase all this. Okay. So V equals, for the big one, its radius is 10, and it's spinning 40 times a minute. So the velocity of that one's going to be 400. So the velocity of this one has to be the same. So I'm going to do V equals RW for this one. Oh no, none of this is right. I'm so sorry.
It's okay.
I don't know why I'm having such a, because you get the 419. I know, remember I had to convert something though. 40 times per minute. I think I had to change it into, oh yes, because W does need to be in radians. Yeah, okay, I was right. So they're telling me that I have 40 times per minute. So 40 revolutions in 1 minute. Oh, that's right, that's right. Okay, I got it. Sorry. So 1 revolution is equal to 2 pi radians. Okay, so now revolutions cancel out, and now I'll be in radians per minute, which is what I need. So that's going to be 80 pi radians per minute. Okay, so does that make sense so far, what I've done?
Mm-hmm.
Okay, so now I have the angular speed of this thing in radians, which is what I need. So now I'm going to go back up to this equation. Let's erase all this. Okay, let's switch colors. Okay, so now I can do, oops, V equals, the radius is 10, and now funny W is 80 pi. Okay, so now that gets me 800 pi for, oh wait, but I think I actually already know the answer. Let me just double check. No, I don't. Yeah, I do. Find the angular velocity of each pulley in radians. Yeah, so here it is, funny W. There it is for the big one. If you do 80 pi and you multiply it out, you get 251 as a decimal. So if I look up at my choices, see how there's a 251 right there?
Mm-hmm.
So I already know that B is going to be my answer. But I also want to see, how am I getting the angular velocity of the little one?
Mm-hmm.
So now that I know that its velocity is 800 pi, this guy's going to have the same velocity of 800 pi. So I'm going to do V equals R times W on this side, but now I know its velocity is 800 pi. And I know its radius is 6, so now I can solve for its angular velocity. So if I just divide both by 6, I should get 419. Let's keep our fingers crossed and hope that we get, if I do 800 times pi divided by 6, oh, thank goodness, we get the 419. Phew. Does that kind of make sense?
Yeah, it made more sense than it did before.
I don't see how, because I totally messed it up. But now I've got it again. Okay, so let me just recap for people watching the video. You're going to start off by taking the angular velocity of this thing, W, which they give it to you as 40 times per minute. But you can't have revolutions per minute. You need to change it into radians per minute. Because if you look at the formula on your reference sheet, it even tells you W has to be in radians per unit time. So we can't have it in revolutions, we need it in radians. So that's what I did right here, was changing it into radians per minute. Okay, so that gets you the angular velocity of the big one. Then if you want to find the angular velocity of the little one, you're going to start off by finding the speed of the belt. Because the speed of the belt is the speed of the belt, no matter if you're measuring it here, over here, over here, it doesn't matter. The speed of the belt is only going at one speed. So that's what this number is right here. So that's the speed of the belt. So I take the speed of the belt and I pop it in, same equation, but now I'm going to solve for the angular speed of my little pulley. And that's all I did here to get that 419. Whew. Okay. What else you got?
Can you do, what was 18 on this?
Okay, let's see. I remember that one being another one that was annoying. So let's, oh, okay, no, this one's doable. All right, so 18, it's a lot simpler than they're making it out to be.
Mm-hmm.
What you need to look at on 18 is you're kind of focusing right here. There's a little tiny right triangle that you're looking at. And what they're basically asking you to do is to figure out what this little tiny angle is right there. So I'm going to draw the triangle a lot bigger over here because it's easier to see. Okay, now they give you some values. They tell you that X is 6 and Y is that super long inconvenient decimal. But on my triangle, that corresponds to this. So this, the bottom side of my triangle would be 6. And then this vertical part over here is that super long decimal 4.2.483154. Okay, so that's that whole side. What you're looking for is, oh, and they're calling it beta instead of theta, whatever. That's just a variable for that angle. That's all that is, like X or theta or whatever. So if you remember from SOHCAHTOA, I just need to solve for this missing angle. So which two sides do I have? Well, if I'm looking at this angle, the side marked 6, which one would that be? Would it be opposite, adjacent, or hypotenuse?
Adjacent.
Yes, so that one's adjacent. And then this side over here would be the
opposite.
Correct. So I need to use which of my 3 ratios if I'm dealing with adjacent and opposite?
Tangent?
Yeah. Yep. Perfect. And that's going to be opposite divided by adjacent. So tangent of my mystery angle is equal to the opposite side, that whole crazy decimal, way to make it inconvenient, over the adjacent side, which is just 6. So now it's just a calculator problem. So on my calculator, remember, when you don't know what the angle is, you have to hit second. So I'm gonna, first of all, you need to make sure that your calculator's in radians, which mine is. So then I hit second tan, and then that whole decimal, 2.483154 divided by 6. And it spits out for me 0.39. So that funny weird angle is 0.39, but remember that's in radians. But if I look at my choices, I already know that the answer's got to be choice A. If you felt so inclined, or say it was in multiple choice and you had to do out the changing it into degrees, remember to go from radians to degrees, you're just going to multiply by 180 over pi. So it's the opposite of what you do to go the other way. And then if you just pop that into your calculator, you should get the 22.483 value. Okay, any other ones you want?
No, that was all I had.
That's it? Okay. So, did you take a look at this week's work, the that dollar folding thingy?
Yeah, I looked at it, and I was a little confused on like how to like answer all of the questions in the folding part of it. But I think I'm gonna try again with it today.
Do you want me to go over any of it?
You don't have to because I don't have any specific questions on it. I was just like confused overall.
Oh, okay. Well, try it, and if you do have questions, feel free to just message me or whatever. But it's really not too bad. I'll just give you just a little brief while we're here. So when you get it all folded, you're basically going to have one side that, well, they're all going to fold into these equilateral triangles. So just remember that when you have an equilateral triangle, what's the measure of that angle right there?
45.
60.
60.
Yes, because remember they all have to add up to be 180.
Mm-hmm.
So you'll have 60, 60, and 60. So there's a typical equilateral triangle, right?
Mm-hmm.
And then what you're going to find out in this project is you're going to have one side, when you fold the bill up, there's going to be one that looks like, oh, why is it not drawing? There we go. One side's going to look like this. It's going to have two triangles kind of like that fold together to make this. And so these smaller triangles are 30, 60, 90 triangles.
Right.
Right? Because you took that 60 and split it in half. And then what they're telling you is this right here, this is the short side of the dollar bill. And they gave you that value as 6. So that's what you're starting with. So you need to figure out what this is right here.
Mm-hmm.
And that's kind of the key to the whole thing. Once you have that, you can basically answer all of the other questions. So without giving you too much info, do you remember if you look at the 30, 60, 90 triangle? So if that's 60 and that's 30. Do you remember how it went? You took the side across in the 30. We always called that one X. That was the short side. And then to get the hypotenuse over here, do you remember what you do with the short side?
No.
You just multiply it by 2. So that's going to be 2 times whatever X is. So if this bottom were 5, the hypotenuse would be 10.
Mm-hmm.
Right? And this is on your reference sheet too. Yep. So there's a picture of the 30, 60, 90 triangle if you need it. And then this back side, this is the one that's kind of weird. You're going to take whatever the short side is and you times it by √3.
Mm-hmm.
So that's the pattern. So it's pretty easy. If I give you something like, let's just stick with 5. If that's 5, that means this is 10 and this is just 5√3.
Mm-hmm.
Now, this particular problem with the folded bills is weirder because this is not, it's just a 6. It's not a √3, right? I just have a 6 there. So what you're basically doing is you're like, okay, if this is 6, what does that mean the short side would have to be? Well, in order to figure that out, you're going to take a look at this right here. To get from this back to that, you divide by √3. Right? So if I did 5√3 and I divided it by √3, that's how I would get just 5.
Mm-hmm.
So you need to do basically that same thing. Oh, whoops, I hit the wrong button. There we go. You need to do basically that same thing, except it's a 6 there. So you're going to do 6 and you're going to divide it by √3. And once you clean up that answer, whatever that is, so I'll put that as a question mark, that gets you what that bottom side is.
Okay.
And then once you have that, you can pretty much do all the rest of them.
Mm-hmm.
Okay, so give it a shot, but do let me know if you get stuck on anything else.
Okay, that makes sense though.
Okay, good. Anything else that I could help you out with at all?
That's all.
That's it? Okay, so I saw that you turned in a bunch of stuff, so that's great. Keep up with it. And yeah, just reach out to me and let me know if I can do anything else.
All right. Thank you so much.
You're so welcome. Talk to you later.
Bye.
Bye.